Logistic regression. So similar to linear regression, we're looking at the odds of an event occurring. And you can calculate logistic regression from either a case control or a cohort study. And here's an example from an article published with N. Haynes data in BMC Geriatrics in 2024. You see this presented both the numbers as well as a graphic representation. And I love the graphic representation here. So that line through 1.0, the 1 is there's no increase, no difference between cases and controls if you've got a case control study, or between exposed, not exposed, if you're looking at a cohort study. Again, it depends which direction you're looking at your data. But let's look at a few things here. And the actual numbers on the right, the odds ratio and the 95% confidence limits, are just visually demonstrated in the middle, again, which I love. So the error bars, so you see, if you're looking first at the PA, and again, this is association of cognitive performance with oral dosage, intensity, and domain, physical activity, and aging. And so it's physical activity, moderate, and very intensive physical activity are what those different categories of variables are. And then you see different levels. So 0 minutes per week, 1 to 149 minutes per week, 150 to 299, greater than or equal to 300 minutes per week. And then the events occurring over the total population. So you're getting an incidence here. It could be prevalence, again, if you've got a cross-sectional study. The odds ratio, you look for all three of these different variables. You have a reference category that the odds ratio are in comparison. Always, if your odds ratio is less than 1, that 1 or unity, there's no difference. Less than 1, there's a protective effect. Greater than 1, there's increased risk. And so the odds ratio then reflects that. If you're looking in that first category of physical activity, all of those odds ratios are less than 1 protective. You see the error bars, and around the little red markers there, those error bars are your 95% confidence limit. So they just demonstrate what you have the actual numbers for. Then the p-value is sort of redundant, really, because the p-value gives you an exact p-value. You'll know if it's statistically significant at a p of less than 0.05 probability, your alpha of 0.05, if those confidence limits don't overlap 1.0. And you see that in that first category of PA, they all but 2 of them do overlap 0, and you can see that in the figure in the middle, and you can see that in the confidence limits in the table, and then the p-value reflects that as well. So 2 p-values that are not significant, and 1 that is really quite highly statistically significant, and you can see that demonstrated as well. Then that last column is a P for trend, and that really is looking at dose response. So there might not be statistically, and you do see this sometimes, the individual odds ratios might not be statistically significant, but an overall P for trend is statistically significant, so that you've got evidence of dose response. And this, again, is beautifully demonstrated in this figure here. So again, 2 of them are not statistically significant. Those 95% confidence limits overlap 1.0. The P for trend is really highly significant. And that makes sense. If you're looking at these, those little markers, they look significant. Now look at that last one. You don't even have to look at a p-value. Those little yellow markers, they're all over the place. So that P for trend, highly non-significant. Even though the 2 of the individual odds ratios are, though not statistically significant, are smaller, 0.07 on 0.08. So a nice example here of logistic regression.